Hello, guys, and welcome to our computer networking course. So, before we actually get into computer networking, let's actually find out what the hell is a network and how internet actually started. All right, so let's have a look at how networking actually began, right? So, the first word that we have is network, right? So, what do you think of when you hear network? Right. So, when I hear a network, now I think of a group of things that have a link in between them, right? They have some sort of connection in between them. That is what comes to my mind when I hear the word network, right? What it actually is that it is a group of some things that are connected to each other and they can affect each other, right? So they can communicate with each other, right? So it is a group of any things connected to each other in a way that they can affect each other, right? They can communicate with each other, right? So basically, you need two things, right? You need a connection and you need communication, right? Connection and communication is what would form your network, right? So, for example, I could have a network of my friends, right? I can have a network of my colleagues. You can have a network of your friends, right? You can have a network of people in your college or people in your school or people in your office, right? All those kinds of things could be concluded under a network. In computer networking terms, the people that we were talking about are simply replaced by hosts or machines, right? So it simply becomes there are some devices, they are connected in some manner. We don't care what that is, and they are able to communicate between them, right? One machine can talk to other machine, can send some message, but they can communicate with each other, right? That is what a network actually is. All right. So, what is an internet? I said that I have a network of people, you have a network of people. Other people also have their own networks of friends or colleagues or whatever, right? So, what if we created a link between all of these networks, right? What if we linked all of these different networks together, right? So, that is what our internet is, right? It is simply a network of networks, right? That is what it is, a network of networks, right? So internet now, it is a conceptual thing, right? So I have a network, you have a network, we connect these two and it becomes an internet, right? I have a network, two of my friends have their own networks and we connect those and it becomes an internet, right? So it doesn't matter how many we are connecting, all that matters is that we are connecting them, right? But when we normally talk about internet now, we are speaking about something very specific, right? We are talking about the biggest, the most prominent form of internet, right? So, matlab, we are talking about the internet where most of the networks are connected, right? The biggest deal, right? That is what we talk about. So this is just bad naming, right? So we had a concept and it was called internet, and then we just named it the internet, right? Very difficult to distinguish between them. So that is how it is. This is also how ducks were named, by the way. You had the verb duck, right, which means to duck, right? To bend, like to squat, right? And they saw that ducks squat a lot. They dive underground. They dive underwater a lot, right? So they started calling them ducks, right? So that is how internet was named. We had a concept called internet, and that was connecting network, right? And we had many such internets, right? And we named the biggest one the internet. All right. So let's move on to how internet began, right? So it all started with Arpanet, right? So Arpanet stands for Advanced Research Projects Agency Network, right? So this was started by your DARPA, right? So Defense of United States of America was the one that started it, right? And as with all things, it was during a very turbulent time, right? So to it was matlab this now the purpose of creating ARPANET was actually to share resources between centers that were geographically separated, right? So there were a few places that had some resources that should be accessible by some people, but they were geographically separated, right? So they could not access them. That was the main purpose to make this, right? And obviously those were for research purposes for your military, right? So that is how it all started. And the way ARPANET was designed was that it had some hosts, and they were connected to your IMPs, right? So IMP is your it's basically a specialized type of computer whose job is to transfer messages, right? That is all you have to know. It is a specialized type of computer that has the job of transferring messages, right? So you have a lot of hosts, right? You have a lot of hosts, and that would be connected to one of your IMPs, right? And this guy would transfer the message sent by this host. Let's say I want this host wants to talk to this guy, right? So what is going to happen is this guy sends its message to him and tells him who to send it to, right? And then this guy is going to what? Forward the message, right, to the imp concerned, right? And then this guy will decide which host gets it, right? So that is how your message was transferred, right? That is how your message would be transferred, right? Moving on, the initial way was that they took four centers, right? So that was your this is basically how we designed it, and there were four main centers, right? So these are all universities. To remember it, you can remember it like Sri Uta, UCLB, UCSB, right? So these are all university, right? These were all research centers that were very big during those times, right? And they had all the resources that were required. So what we did was we connecting these four main centers, and let me show you the way this actually happened, right? So this is how it was connected, right? These were the four places that needed to be connected, right? These were the four places that needed to be connected, and there were lot many hosts, right? So now why we require an imp should be becoming much clearer, right? A specialized computer was required to manage these many messages, right? There would be a lot of clutter if we allowed everything to access everything, right? They would, it is required, right? You can probably see why it is required now, right? There needs to be some sort of order that needs to be maintained, right? So this is how it was. We had four major places that we had to connect, and we connected those four, and we said that data could transfer over this now, right? So that was your original network. Let's move on to the spread of internet, right? So the internet started in 1969 with Arpanet, right? We already talked about that. Arpanet also brought with it something called NCP, right? That is your network control protocol. This is what evolved into TCP/IP, right? As we know it now, this is what evolved into TCP/IP. So that was, if we are talking of internet as a wildfire, ARPANET was the spark that started it, right? So sometime later in 1972, Windsurf and Bob Khan were the two people who introduced gateway, right? So for now, we were doing a very wasteful thing, right? We were using specialized computers just as a gateway, right? So what these guys did, what that they said that we don't actually need a full computer for it, right? We can just have a simple gateway, and it doesn't need to be a full computer, right? It just needs to, there needs to be some hardware that does that job, but it does not have to be a computer, right? So they created a gateway for it. And then in 1973, another year later, they they created TCP/IP, right? They helped NCP evolve into TCP/IP, and that was what fueled the fire even more, right? That was what fueled the fire even more. A little while later, a little while later, that wildfire spread so far and wide. It spread very wide, right? So what happened was we had our ARPANET, right? This was all ARPANET, ARPANET, ARPANET till now, right? This was all ARPANET, ARPANET, ARPANET till now. Now what happened was ARPANET got divided into two, right? Into two specific purposes, right? The first was Milnet, that is a military net, all the military purposes, and the ARPANET, whatever was left of it, was for all other purposes, right? But what the problem was with this was that not everybody was allowed access to it, right? I mean, this is obvious, right? It is a defense agency. Not everybody will be allowed access to it, of course. So, CSNet was created, right? And CSNet was simply, it was simply ARPANET. It was like ARPANET, but it allowed other non-government authorized people to join as well, right? So we are not talking about people here, we're actually talking about organizations, right? So there are other organizations, other universities that wanted to join this but could not, right? Because it is a defense agency and not everybody can be allowed access to all of that information, right? So CSNet was created for such a thing, and it was a huge success. With that success, what happened was we created NSFnet, right? So this was again, matlab CSNet was also created by NSF, and NSFnet is also created by NSFnet, right? So they saw that CSNet was such a huge success that they created NSFnet, and what they did was they took 5 supercomputers and they said that this is the backbone. So anybody who wants to join this network, you all you have to do is you can connect to one of our servers, right? And you would gain access to all the information, right? That is what happened. So matlab this was CSNet was basically was for all the universities, all the research institutions, and all those organizations, right? NSFnet allowed even small organizations, even individualistic peoples to join our network, right? What happened was this spread the wildfire so far and wide that NSFnet was not enough, right? We had to scale things up to accommodate the incoming traffic. It was so huge that we had to create another network just to scale up our NSFnet model, right? So ANSNet was created for just that purpose, right? It was scaled up version of NSFnet. All right, so moving on. After that came the real boom of things, right? So Tim Berners-Lee, he created Wide Web, and that in 1990s, right? He created World Wide Web, and that was what created the internet boom of things, right? So as you know, today's internet is ever changing, right? It does not have defined paths. What it has is ley lines, right? So what ley lines are, it is a point to point connection, right? So for example, I'm saying I want to connect to this guy, right? And when I say it's a ley line, I would simply be drawing a simple straight line, right? But what actually happens is that it would go somewhere here, then here, then here, then it would travel a very ragged path before it actually reaches this, right? And this path that it travels is not always the same, right? It is ever changing. Sometimes it would travel this path, sometimes it would travel this path, right? It could travel a new path any number of times, right? It does not necessarily need to travel the same path, right? And that was how our internet evolved from Arpanet. Let's move on. So since this was so far and wide, we needed to have some sort of rules, right? Some standards upon which we can build things, right? So that is what our protocol and standards are, right? So protocol is basically your rules, right? So for example, let's take the example of normal communication through our mobile, right? So what do you do when you have to talk with somebody? You pick up your phone, you unlock it, dial the number, press the call button, and you say hi, right? That is what happens. And then the other guy would acknowledge that, and he would say hi, and you would ask, are you this or are you that? And then he would reply, yeah, or you would recognize the voice, but there would be some sort of check, and then you would proceed with your normal communications, right? So there are a set of processes that you are following, right? You're picking up your phone, unlocking it, dialing the number, pressing the call button, waiting for the guy to pick up the phone, saying hi, waiting for his reply. Like these are all what? These are all rules that we are following to make sure that the communication happens properly, right? So this is what a protocol is, right? It is what a protocol is. In our networking terms, we are only concerned with the communication part of it, right? So protocol is what defines how things are being communicated, how things are transported, right? When they are transported. So for example, if I want to send a message, let's say I want to send ABCD, right? It doesn't necessarily mean that my protocol is actually going to send ABCD. It might send CFCDFG, but on the receiver end, the guy hearing it should receive what? ABCD, right? There can be a set of rules that does that conversion for you, right? It could be that it is sending some more information along with what I sent, right? That is also a possibility, right? So all those things are decided by who? Your protocol, right? So basically, your protocol would be deciding your syntax, your semantics, and the timings, right? Standard, right? So if that was your protocol, what is your standard? Standard is simply your agreed upon rules, right? So if you have a protocol, well, I can have my own protocol, right? I can make my own set of rules. Okay, I'm going to do this. This is how I'm going to call. This is how I'm going to talk, and that would be my protocol, right? A standard is the accepted part of that, right? So if I make a set of rules and nobody accepts it, nobody uses it, what's the use of it, right? No point doing that. So that is what a standard is, right? Standard is simply the rules that have been agreed upon, right? So basically it says that it should be useful, it should be understandable, and it should be meaningful, right? So there are two types. One of them is by fact, de facto is what do we call it, and the second one is de jure, which means by law, right? So, matlab, de facto is basically what says that this is so obvious that if you don't do it, you're just stupid, right? This is valid. This is a standard by fact, right? It is happening by fact, right? For example, if we are talking about a phone, if you do not unlock it, if you do not unlock it, how are you going to dial the number, right? If you do not dial the number and you just press the call button, it won't work, right? These are all by fact, right? These are all by fact. If you don't do it, it won't work, right? Then you have the jure, that is by law. These are what is conventional things, right? These are all the conventional things. So you do this because everybody has agreed upon this. This is what we are following. This is the norm that we are following, right? That is what it means. So for example, when you pick up the phone, you say hello, who are you, or something on those lines, right? So that is by law, right? That is by convention. So I hope the difference is fairly clear between what a protocol is and what a standard is. So let's move on to how we can actually find out what a standard is. Before we actually move on, now let me clarify something. Not all protocols are standards, and not all standards are protocols. I'll give you time to think on that, and we should move on to how we can make internet standards. Alright, so it's a fairly complicated process with a lot many steps. So let's see how we do it, right? So first of all, what you have is an internet draft, right? And that is your work in progress, right? So I'm making my protocol, I'm blah 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 blah, I'm writing down stuff, I'm doing things on myself, and that is my internet draft. And then I post it somewhere, right? I make sure that the people who can do something about it know that this thing exists, right? They know, like, you can post it on a forum. There are specific places where you can post these kinds of stuff, right? And what would happen is, if enough people show positive attitude for your draft, what is going to happen is somebody is going to initiate a RFC, that is your request for comment. That simply means that, okay, we have seen this feels useful, let's take this into consideration, right? Let's take this into consideration and move forward with the testing parts of it, updating parts of it, optimization parts of it, right? So that is what happens. And once that is done, what would happen is that you would make a proposed draft. That simply is that you had an internet draft, you had some ideas, you formulate it properly, make sure that it is stable, make sure that it is understood, make sure that it is of interest to at least a decent amount of people, right? So if it is not stable, it's useless, right? We don't want that many errors. If it is not understood, it won't be able to proceed for any further, right? That those parts are obvious, right? The third part says that it should be of interest to a decent amount of people, and that means that if most people don't want to use it, this probably should not be a standard, right? Why would you make a standard for just you and your friend, right? You can just use whatever you want for that purpose, right? So if a decent amount of people would be interested in it, you move forward with it, right? And once that happens, what you do is you move on to the testing phase. After 4 months, after 6 months, and at least 2 successes, you move on to draft standard. So you are promoted now after 6 months, and at least you need at least 2 successes within those 6 months to move on to your draft standard, right? And once you are in your draft standard, what happens is you're going to update stuff, you're going to optimize stuff, you are going to resolve all the bugs there are, resolve all the problems there are, and do a scale testing, right? So this has to be completed in your next 4 months, right? In the next 4 months, again, you need two successful demonstrations. Like when you have actually demonstrated, okay, that this thing works, it works on scale, it is a proper thing, it is useful, and everything and everything and everything, then and only then do you move forward to your internet standard, right? That is when your internet standard would be established. There are more stuff, right? After this, there are some deprecated stuff that goes away, right? Obviously, you cannot say that this is the standard for forever, right? It can't be that. So it gets outdated at one certain point of time, right? It gets deprecated, and we have separate levels for that. There are experimental phases; those are like different from these. So, those would run parallel, right? Those would run parallel to this. So this is how you would go about getting a internet standard up and running.